Hello everyone and welcome to the chapter number 57 of Blender Master Course, Tracking Constraints in Blender. In the previous chapter, we discussed about the basics of constraints and also covered all the transform constraints. And in today's chapter, we'll be understanding about the working of all the tracking constraints. And for those of you who are new to this course, you can check the previous 57 chapters from the link of the playlist given in the pinned comment. Now we have opened this Blender file, and to access the tracking constraints, go to the Object Constraint Properties, then click on Add Object Constraint, and for the objects in the scene, we have these 5 kinds of tracking constraints. So the first one that we have is the clamp to constraint. So let's add this. Now this clamp to constraint simply clamps or locks the position of the object on which it is applied to another object, which will be the target object. For example, if I go to the 3D viewport, press Shift plus A, then go to curve and select the Bezier curve. Let's tab into the edit mode, scale it up like this. Let's also go to the top view by pressing 7 on the numpad, and to control the way this curve looks, we need to add some more points. So right click and select subdivide. We'll repeat this step 2 to 3 times so that we have a high number of points. Then to change the position of these points, I'll simply select them and press G to move their position. I'll place it over here. Let's also select this one, move it over here, and if you want to change the way how your curve looks, then you can select any of these handles and press G to move them. Now the curve looks perfect, so we'll come out of the edit mode. Now if I select the cube again, and in the object constraint, I'll go to the target object, and with this eyedropper tool, I'll select the Bezier curve. And now you will notice that if I try to move this cube, then we can't move it freely because its position is now locked according to the target object or the Bezier curve. And this is the use of the clamp to constraint. This object constraint will simply clamp the position of your object as per the target object selected over here, which is the Bezier curve in this case. Also in the clamp to constraint, you have an option which is the cyclic, and if I turn it on and try to move the curve like this, then you will notice that after it reaches the end, it will again appear at the beginning of the curve. So if you want, you can try to create an animation with it where the position of a particular object will depend on a Bezier curve simply by using the clamp to constraint. Now we'll move to the next object constraint, which is the track to constraint. So first of all, I'll delete this cube and also the curve that we added over here. So press X to delete, press Shift plus A, go to mesh and select the monkey object. Go to the object constraint properties, and in the add object constraint, select the track to constraint. Now by using the track to constraint, you can make the local axis of an object always point towards another object which we as the target. To understand it in a better way, we first need to understand what exactly are the local axis of an object. So for this, first go to the object data properties, then in the viewport display, turn on the show axis. Now you will notice that on this selected object, we are having 3 axes: the X axis, the Y axis, and the Z axis. However, these 3 axes are different from the global axis present in the scene by default. And this is because if I try to rotate this monkey in the Z axis like this, then you will now notice that it is pointing the Y axis in this direction. However, in the scene, the global Y axis is represented by this green line. Similarly, the local X axis of this object is also in this direction, which is different from the direction of this red line in the scene representing the global X axis. So each of the object has its own local axis: the local X axis, the local Y axis, and the local Z axis. Now let's go to the object constraint properties again, and now for the target object, I'll be selecting this lamp. So click on this eyedropper and select the lamp, and now by using the track axis, you can define that which particular local axis should be pointing towards the light or the lamp. By default, the minus Z axis is selected, and as a result, you can see here that the local minus Z axis is pointing towards the light. Similarly, if I select the X axis, then in this case, you can see here that this local X axis is now pointing towards the light. Then over here, you also have an option which is known as the up, and this one will control that which particular local axis should be in the upwards direction. For example, with the Y axis selected by default, you can see here that the Y axis is pointing towards up. Similarly, if I select the Z axis, then the Z axis is pointing towards up. And now suppose you want that the face of the monkey object should always be pointing towards the light. And for this, you need to identify that on which particular local axis the face of the monkey lies. And if I look closely, then the local Y axis is present at the back of the head, and as a result, the front face of the monkey object must be present on the local minus Y axis. So in the track axis, if I select minus Y, then now you will notice that the face of the monkey is now pointing towards the light. Also, if I try to move it in any direction, then you can see here that the track to constraint is causing the minus Y local axis of this particular monkey object to always point towards the target object, which is the light in this case. Now the track to constraint is very important because in most of the cases, you will either be using the clamp to if you want to lock the position of your object to a target object, or this track to constraint if you want the local axis of your object to point towards the target object. Also, the other 3 constraints that are left, which are the damp track, the lock track, and the stretch to, are also very similar to the track to constraint. And now we'll be moving towards the next type of object constraint, which is the lock track constraint. So first of all, I'll remove the track to constraint from here by clicking on this cross icon, then go to add object constraint, and in the tracking category, select the lock track. Now this one is also very similar to the track to constraint, and the only difference is that it will make the object on which it is applied to point towards the target object only along a particular axis. To understand it practically, I'll go to the target object, click on the eyedropper, and select this light. Now in the track axis, the Y is selected, and as a result, you can see here that the local axis which is pointing towards the light is always the Y axis, and similarly, if you want the face of the monkey to point towards the light, you can select the -Y axis in the track axis option. However, you can see here that whenever I try to move it, it is not looking up and down and not even tilting its head, and this is because of the locked axis over here. By default, the Z axis is selected, and it basically means that the only axis in which the monkey will rotate will be the Z axis, and so this is the use of the lock track constraint. However, as I already told you, in most of the cases you won't be using this, but instead the track to constraint that we previously discussed. Now moving ahead, we'll be understanding about the next type of object constraint, which is the stretch to constraint. To add it over here, first I'll remove the lock track by clicking on this cross button, then click on add object constraint, and in the tracking category, select the stretch to constraint. Now the stretch to constraint also works in a very similar way to the track to constraint, and the only difference between the two is that in case of the stretch to, the object will begin to stretch or show some contraction depending upon the distance between the constrained object, which is the monkey, and the target object, which will be this light. So first of all, I'll go to the target object, click on this eyedropper, and select the light object, and now you can see here that if I try to increase the distance between the two objects, then the monkey object will show the stretching, and if I try to bring them closer, then in this case, the monkey object will show the contraction like this. And yes, by default, it takes the original distance between the two objects to determine the stretching effect. However, if you want to input any particular distance value, then you can go to the original length and change the distance from here. Also, if I click on this cross button, then it will take that particular value as the distance which is originally present between the two objects. Now the next constraint that we'll understand is the damp track constraint. So to add it, first we need to remove the stretch to constraint, then go to add object constraint, and in the tracking category, select the damp track constraint. Now just like the other two, this constraint is also very similar to the track to constraint that we previously studied. The only different thing in this particular constraint is that it does not give you the option to control the up axis over here, because if I go to the add object constraint and select the track to, then here you can see that we were having the option to control the up axis, and this particular option is not present in the damp track constraint. For now, I'll remove the track to constraint, and in this one, I'll click on the eyedropper for the target object, and with this, I'll be selecting the light in the scene. Now since the track axis is selected as Y, as a result, the local Y axis of this monkey object is pointing towards the light. If you want the face of the monkey object to point towards the light, then simply select the -Y axis over here, and now if I try to move this monkey, then you can see here that the damp track constraint will basically take the minimum amount of rotation which is required, such that the local -Y axis of your object will keep pointing towards the target object. So this is the use of the damp track constraint, but again I'll be repeating this, that in the entire list of the tracking constraint, you should only focus on the clamp to and the track to constraint, because these are the ones which are practically used in Blender. And with this, we now arrive to the end of the chapter number 57. Today we understood about all the 5 types of tracking constraints, and in the next chapter, we'll be understanding about the relationship constraints. So our next chapter will be the chapter number 58, relationship constraints in Blender. So don't forget to subscribe to our channel, press that notification bell so that you can get timely updates about the upcoming chapters. Thank you for watching, and we'll see you in the next one.